welcome to this edition of Shop Class with I2r. And this one kind of hits home for me. I was just talking with Sonny about how I have been trying to add CNC to my workflow for probably 6 or 7 years now. And I've gone the route of buying inexpensive kits, putting them together, and as soon as I get it set up and running, I do what the task that I need to do, and then the next month I pick it up and it's not working again. And I have to figure out the programming and I have to jump through all the hoops. And most of our listeners and readers know I'm a fairly tech savvy guy, and it has proven to be very, very difficult for me to keep my little CNC that lives in the corner of my shop running. And in fact, about 2 years ago was the last time it was running, because I know it's going to take me a week to get it going again. And I am a huge fan of these great turnkey systems that are coming out. And the moment I saw the I2r setup, I was really, really stoked. And I think you'll see why. It's just one of those, get it into your shop and you're going to be running in a couple of hours. And Sonny and Fu are going to show us both about the machine and tell us what to look for in a CNC machine and what the important aspects of a CNC machine are. They're also going to show us the software, specifically VCarve, and show us how simple it is to import something into VCarve and get working with it immediately. So without further ado, I'm going to hand it off to Sonny. Sonny, I'm unmuting your microphone right now. And if you can click that camera button, there we go. Here we go. Gentlemen, take it away.
All right, just a quick check. You can hear me okay?
Yeah, I got you.
Hey, everyone, and thanks again for joining us today. I heard you had some great weather out there. We had amazing weather too. Just want to thank you all for taking the time to join us here at I2r in New York. On today's show, our goal is to basically introduce you to the design concepts of what makes a machine great. So here at I2r, we really believe in designing from the bottom up, and we really believe in an all-inclusive system that is easy for the end user to pick up and learn. CNC technology, I'm sure you've seen it around for many years, and I'm sure that you've been thinking about maybe adding it to your workflow, like Ben mentioned, or even adding it to your shop, but just haven't really gotten to being able to break down exactly what to look for. So hopefully by the end of today, we can break that down for you and you can get a better understanding of what it is that you want in a great machine. Okay, so this is, we're gonna get started here in a bit, and this is Fu, by the way.
Hey everybody, Sonny's gonna go over some of the features in our CNC machine, what to look for when you're in the market for a CNC. A lot of you might be looking and thinking it's very difficult to learn. It seems kind of scary to get into it. So today's goal is kind of to show you that maybe that's not true. Because the software side, some people think, oh, I have to spend hours and hours researching before I could design something on the computer. So later on, I'll show you that it's quite simple. The Vectric software is very easy to learn. We're going to be using this example later, which is basically a inlay cutting board that we made earlier. And we'll kind of show you some of the process we took to create this project. For now, I'll let Sonny take over and talk about the machine. I'll see you guys in a bit.
Okay, great. Thanks, Fu. Appreciate it. So I think as Ben had told you earlier, he's got one of those DIY Build-A-Kits. Those machines are very good in the sense that if you're a beginner, you can at least take the basic components and learn about every component. But what you might think in cost savings at the beginning, it's probably going to end up costing you more down the road, as you're going to find yourself constantly looking for upgraded parts. You're going to try to add to the flex in those machines, because those machines typically are a system that's driven by a ball screw and pulley. I'm going to show you here very quickly in a bit the difference between all those systems that are available out there. Okay, so A little bit about the I2r Cnc. This one here is the I2r 8. It's a 2 foot by 4 foot cutting space. And then we have two other lines that come in the 115 volt system. That's the I2r 4. That's a 2 by 2. That's our smallest. And then the I2r 6 is our 2 by 3 foot cutting square area. We have larger systems for industrial applications, but as far as getting started and being a first-time user, even middle tier, there's a lot of different systems that we offer for different levels, and the I2r is the perfect starting point for that, okay? We've taken from our industrial applications on the larger machines and shrunk it down to a desktop size machine for you, but even though it is pretty lightweight, it's around 200 pounds, it does the job, and it's built like a tank. So let's get started on going from the ground up, okay? So like any good system, you want a solid base, a solid foundation, right? So starting with the stand here, this is an add-on. It's all steel. It's got industrial casters, so it's easy to move around. It is quite heavy if you're trying to lift it by yourself. So when you're in the shop, you need more room and space. It's easy. You can just quickly push it to the side, pull out your other tools, and get to work. It also comes with a great arm. It's very useful for mounting your laptop. You can control the system. You have a good view of everything that's going on while you're machining. Underneath the bed, the stand is also open. So for maintenance purposes, it's very easy to access that. You can get under there very quickly. If you ever have to do some standard application for grease or oil, it's done in less than 2 minutes, okay? Now, this machine is a 3-in-1 system, and it's also all metal. So the machines that I guess Ben has in his shop, that's going to be plastic, and those are around like your $1,000 entry point levels. When you're talking about high-speed machining, you don't want to have any plastic components, right? You have a lot of inertia going on in there, so you're not going to want any plastic. That plastic will melt or it'll crack, okay? We're talking about high speeds, high velocity, okay? So let's talk about our machine here. From the base up, you have an aluminum extruded table. Underneath this black frame here, you have 30 millimeter thick extruded aluminum. They're interlocked, okay? So it's very stiff and sturdy. It provides a solid base. On plastic machines or smaller machines, you're gonna find it flex toward the center because the frame is not properly grounded. It's not flush with your spindle. That's not something you want, and that's not something you'll see in our machines. You can see that this is a very solid base here, and it can hold my weight. I don't weigh that much. I weigh like 160 pounds, but just to let you know, since you're not here, we can move on here to the gantry. So the gantry on this, we have two, and the gantry is what holds the machine together. You have the crossbeam, and that crossbeam is 1 inch thick, also aluminum. We have 1/2 inch thick on the gantry that's holding up the spindle and the crossbeam. We also call that the bridge, okay? So when we're talking about this 1/2 inch aluminum, there's other systems out there that cut corners. They'll use plastic as a majority of the thickness, and they'll plate it with a very thin sliver of plastic coating on there. And then they'll market it as it's aluminum. But really, you only have an 1/8 inch thick aluminum plated on top, and it's really being held together by plastic. So you gotta look out for all those marketing schemes out there, okay? Another thing we can move on from there is I talked about the 1 inch aluminum thick plating here. That's the crossbeam. It holds the most important feature of our design here for a Cnc. In industrial application, $100,000 machines out there, you'll find that they use only ball screw prismatic linear rails. The reason being is because they provide for very, very tight tolerances, accuracy, and high-speed machining capabilities. You can accelerate and decelerate very quickly. On systems, there are other ones out there like driven by lead screws. There's also systems like the belt and pulleys that I mentioned, and also there's the rack and pinion systems. Those have gearboxes in them. They're great. They're cheap at first for the startup costs, but for the lifetime of the machine, you're going to spending more money being that you're going to replace those parts, and it's going to have a lot of kickback, okay? So what makes a ball screw system so great is the fact that if you think about ball screws, they have a ball bearing. So that ball bearing minimizes the friction, and you can distribute more weight loads across the surface area. Not to get too technical, but just know that it's the combination of the build. So when you talk about the prismatic linear rail and the ball screws are rolled. That's the manufacturing process that it's made. And these are steel components, okay? And when you're pushing these ball bearings at high rates, because of the less friction, you get 0.15 millimeter precision, repeatability, and accuracy on our machines. I'm not too sure about what other machines out there are doing, but this is the one for ours, and it's just our entry level. So another great thing about ball screws and linear rails is the longevity and the maintenance, right? So when you're talking about maintenance, because the ball bearings are enclosed and preloaded, you're not going to get a lot of dust and debris as you're cutting, getting in and getting in the way of the ball screws. And on top of that, you have these strong NEMA 23 stepper motors, right? So it's driving very ferociously this spindle head, which I'll get to in a minute. Okay, so sorry if I got a little technical there. I tend to go in a little hole, but that's something you should understand, and you should ask those kind of questions. Also, like you'll see behind on the mounting position of our spindle mount, there are carriages here. So when you're testing a machine, check on the Z-axis because that tends to be the weakest point. So you want to check for flex, right? If your spindle is flexing and going about the up and down motion, that means you just got weak positioning there. And you don't want that when you're cutting, especially when you go up and down. That's going to affect your performance. Okay, so let's talk about the spindle, okay? This spindle, it's a 1 horsepower spindle. Its standard outlet is 115 volts, but it's powered by a VFD inside the control box. So what that VFD stands for is variable feed drive. So what it's taking that 115 volts from your wall and pumping out 220 volt 3-phase, okay? So even though you might hear it's 1 horsepower, it's not your standard router, okay? It's an air-cooled brushless electro spindle, okay? It's going to be much quieter, and it's going to be able to shred any type of material you put in front of it, okay? Now you have to understand that this is also a moderate level to entry level machine, so it's not going to be cutting steel, but it'll be able to cut any other material of metals, like non-ferrous metals, so that's similar to like your aluminum, your copper, your brass, stuff like that, and then anything softer. So softer materials, we're talking like plastics, foam, cardboard, cork. We have all sorts of different applications for these machines, and businesses rely on them on a daily basis. Okay, so what it's going to hold is a 1/4-inch shank for the bit, and you can even put down an 1/8 inch. We have an ER11 cullet in there. Now, another cool thing that comes on your machine here is you're going to have your limit sensors on every axis. So when I say axis, I'm talking about your x-axis being your horizontal. The y-axis is the front to the back of the machine, and the z-axis is from the ceiling to the ground, okay? So those are your 3 main axis machines that you're talking about when you're talking about standard 3-axis routers. One of the great things about this is the limit sensors. There are sensors on each axis that allow the software in our program to tell exactly where the bit position is in relation to the travel of the machine. So this I'll go into later further detail when we get to the computer side. This is a very, very capable system for you to have, because you'll find that if you don't, you'll probably end up trying to crash the machine onto the sides or go out of the limits for the positioning. Okay. Now, 3-in-1 machining is another thing that is a pro for this machine. When you look at a CNC, people are probably going out there, there's cutting costs buying 1 mil, and then they're going out looking for a laser machine, and then they're looking for other tools. So for us, why not build it all in one? You're spending a great deal investing your money and hard-earned time and money in this, so why not do a 3-in-1 system where you have the ability to not only do your traditional 3-axis milling, but you can do your 4th-axis rotary and also laser, okay? So let's get into the accessories. When you buy a machine, you also have these accessories that we have add-ons. So we have a dust shoe system. This is magnetically mounted, which we don't have right now on the display, but you have an overarm that you can purchase. It's got a 2.5-inch hose, and that basically connects to the front of this dust shoe. So when the machine is cutting, you apply your vacuum, it will suck up and keep the entire area clean. When you're not machining, you can easily remove the brush. Okay. Okay. Every system also comes with an automated Z touch-off tool. So once you plug this into the system and put it on top, this will automatically calculate the tool length that you put in there. So this really streamlines your workflow. I'll put this in our toolbox. Okay. And then you obviously have your 2 wrenches that come with the machine when you're trying to adjust your collets. Another great thing about this machine that you have here, you might be wondering, what are these? This is the MDF spoil board, okay? So this allows for reusable protection of the machine bed. It allows for quick clamping and hold down for various types of clamping solutions to hold down your material. This comes standard for every purchase of the machine. Okay, let's move on to the fun stuff, the lasers. This laser is easily added via magnets as well, and you can simply remove it. So a great way is you could probably start machining a project. Once you're done, you can start engraving around your traditional 2D cuts, and that leaves a very nice feel. I'll give you some samples here. So this is our 6-watt laser, okay? It's a laser diode. It operates on the ultraviolet blue spectrum of lighting. This is also an add-on feature that we have. And then you also have the ability to add on, because of our software, it's called the Xy Cnc, this beast right here. This is a 15-watt laser, okay? Now, just so you know, these lasers aren't going to be cutting as fast as your CO2 lasers, but as far as everything's concerned in a 3-in-1 CNC system, this is the most powerful system you can get right now at an entry-level price, okay? You can do all sorts of cutting from plastics. We mostly use this for grayscale lasering on wood, and you can get very high detailed resolution and cool images done. I'm going to show you some examples right now, okay? So starting with our Star Wars fans, this one was done on our 15-watt, and this took less than an hour. So what's great about the 15-watt is because you can machine and engrave a lot faster as opposed to the smaller 6-watt. This one was done on the 6-watt laser. This took about 2.5 to 3 hours. And then you can even do picture frames out of wood if you like, kind of like this one, Everybody Loves Arnold. You can see the burning that we did after, and then we did a profile cut around the edges. Okay. And then we'll also be showing you how we did this project later, the Predator. We finished this with epoxy coating. And then, as I mentioned earlier, if you're doing a 2D cut, you can finish off your CNC and then put even your custom logo on here with the laser. Okay. All right. So we talked about the laser cutting. Let's talk about the 4th axis, which is another accessory. So you can really unwrap the potential of your 4th axis by doing these cool and amazing 3D cuts on there. So instead of doing it by hand, and you imagine having to repeat this 30 times for a customer, it's never going to give and miss a step. Now, other items that people have made, we have businesses making pool cues for them. We made a mini baseball bat for self-protection here. Just kidding. More Star Wars fans, lightsaber, okay? You'll see how this was made also. Chess pieces are another. Let's get a good close-up here. All right, so you can take anything you have in your mind and create it. Okay, let's talk about the other materials. So let's move on to other materials like plastic. The machine can do acrylic, all types of other, whatever plastic you think of, this machine is capable of doing. You can do foam, carbon fiber. We have businesses using it to make drones. PCB for computer components. Moving on to aluminum. 3D toolpaths are another cool way to do your cuts, and especially we tried it on aluminum, and you can see that this came out pretty nice. And then there's a ball opener for a regular 2-dimensional cut. This is copper, so this can be used to, keep your hands clean from COVID. If you're pressing elevator buttons, opening door handles from the bathroom from people who don't like to wash their hands. Okay, and brass. So let's get a close-up of the brass here. I'm not sure if you can see. Is that clear, guys? I think that is right. Here's a dinosaur T-Rex. Here's a seal of the eagle. Try to get focused there. Awesome. And then you can even we have customers that make knives with our machines and handles, holsters for pistols. Let's show you some other 3D type of cuts. Here is another Star Wars edition of the skull for a stormtrooper. Okay, you can see that the finish is very clean. There's very minimal sanding done on this. Here's a bear head. And then a last one for the 3D, here's like Pyramid of Giza that we did, okay? So whatever your imagination is, that's the only limitation. You can get a lot done with the CNC. And for me, I always say, love this one. So you can do let me get you a good angle. So you can do your 2-dimensional cuts here and then put in your 3D, and then you can even finish it with a laser. So CNC machining is a great tool, and it's not as complicated as you may think. I always say I'm a dumb Marine. I was able to figure it out. Anyone can. Okay. Let's talk about the bits, okay? This is just a quick box we made to hold our bits in the shop. So just to quickly walk through the type of bits that we use. These two are your conical ball noses. These are great for finishing the touches off of your 3D projects, like the bear I showed you and the skull. This is an O flute bit. These are great for cutting aluminum, soft metals. Also, there's plastic bits that look just like that too, depending on the manufacturer. You also have these V bits. They come in 60 degree, 90 degree, and larger. These are great for sign making. This is your surfacing bit. We use this to resurface our MDF spoil board, like I told you earlier. And this is your standard end mill. This one's a compression bit. It's going to be used for up and down cutting forces. This is an end mill. This is a ball nose. This is going to be good for your larger 3D finish jobs. And also you have an end mill down cut and then your smaller 1/8" bit here. Okay, so enough about bits there. Let's go back and talk about our software. So just like any design that you put all the work into the mechanical side, the software side is just as important. The brains, okay? We're going to talk about the brains of the system here. There's a lot of archaic type of controller systems out there. They're analog based. They're usually handheld, and they will operate off like a USB. And basically what that is you have to do your design, you get it put it into a USB drive, you put it into that controller, and that controller is the little chip that's what's telling your machine what to do. We've sort of moved away from that. We see the future as digital, okay? We see the internet as a powerhouse. Everywhere you go, everything has computer functions involved. So as I mentioned, we have larger machines like our executive. Those are used for machining metal, and they're used in high-end production. And we use PC systems and computers for that. And you'll see those on even larger systems. We need those because, one, they have a lot of ability to help you as far as computing power. And let's talk about streamlining to the internet. You don't need the internet to run this system, okay? Just so you know, but it is a great powerful tool to have when you are connected to the internet. Okay, reason being, one, a support standpoint, and two, when you're designing, when you want inspiration, you can go online, grab a file, even if you made it yourself, you can purchase it, download it, grab it, and load it right here into your software, and you're off you go. You're machining in one click. So just to give you the setup, the basic setup for this is, this software is called I2r Cnc. Okay, we've engineered it with our team in Europe, and basically that software is run off of Microsoft OS, and that OS system is connected with an Ethernet, and the Ethernet is connected to your control box in your system. Now, everyone is using a computer to start off with for designing their work. So once that's done, basically I'll walk you through. If we do a quick load button, right from here, you just open just like any other normal file. And this is the Batman inlay that we worked on before this show. And we're going to show you some quick clips of the machine cutting. But it's just that simple. Once you have your design, you take that, upload it into your machine, and there it is, okay? Another neat feature about this software is the configuration. You have a lot of versatility, okay? You have the ability to add additional plugins that run your laser, your fourth axis. You also have plugins to run wireless handheld controllers. So I'll show you that in a bit. After that, you can even use a gaming controller if you don't want to purchase our add-on. But for starters, we use the keys on our PC. So as you can see, this yellow dot here handles the motion of your axis on your spindle, okay? And what it's doing is it's live tracking our position. Remember I told you about the limit sensors and how the machine knows where it is? It's talking with our software here to know. So right now, this is where my machine would cut this wing of the Batman logo. You can even get a 3D view and zoom in on the type of toolpath on the number of it's at. And then this blue cone is the current position of where the center of our material is. There's a lot of ways you can streamline your work here, is because while the machine is running, you can adjust your feeds on the fly without stopping the work. You can quickly slow down your spindle RPMs. Okay, so right now we're set to 24,000 RPM. That's the max of the spindle. Okay, and let's show you the addition. This is the add-on. This is the wireless add-on. We can use it to jog the machine as well. People sometimes like to buy this because it gets them a very pinpoint accurate position. So let's say we wanted to control the fourth axis. You don't need this handheld. We could all do it from the computer also, but this is a great way to show you. Let's see the limit sensor work when I was talking about it. So let's say we kept trying to run into the side. The software just told us, hey, you need to go back. You're out of limits. Okay, great. Now, I mentioned to you about support. We have this diagnostics tab. This might look like gibberish to you, but it should, because you don't have to worry about that. Our techs can log into your machine and help you troubleshoot and figure out what's going on. You don't need to waste numbers and countless of time and countless hours trying to figure this out on your own. And even if we try to call you and walk you through it, that wastes your time. We want you up and running and machining. You shouldn't have to worry about troubleshooting your machine. So this makes the software a very, very powerful tool for us. And that's why we connect it to the internet. okay? There's nothing that you can beat out there that has this feature. Okay, let's talk about the plugins. I already showed you the gaming controller options. I already showed you the wireless handheld. One more thing also I wanted to show you was to go over the laser function in this, right? The laser, there's a plugin in there which you could load. Pull it up. This is the plugin. We have this plugin, and it's a very powerful plugin because it's as easy as taking an image, opening it, you set the dimension, the size, and then you set the feed rate. I wanted to go 3000 to save some time. This is going to take 2 minutes and 40 seconds. I create my code. I go back to my run tab. There's my lion head. I click the cycle start button and off the laser goes. The great thing about this software is also when it comes to laser, it is very good at being able to render such high detailed images because of the ability to move the gantry as well as turning up and turning down the laser simultaneously. We also have this feature available in VCarve. They offer that. But honestly, this image quality and finish is much better than what we have on our VCarve. But both are very good, okay? So I hope you kind of got an understanding of what to look for in a CNC, and I hope I kept it entertaining for you and I didn't get too techy. If you have any questions, feel free to ask at the end of this show and we'll answer them. Now, Fu is going to go over to the computer there and he's going to share his screen and show you how we made the inlay on the Batman logo. And he's going to walk you through how we started from the very beginning of having our idea, which was the Batman logo, creating an inlay, and then to the finished work on cutting it out. I hope you guys enjoyed my portion. I'm going to hand it off to you, Fu.
All right, guys.
Thanks.
Hopefully you guys enjoyed that. If you have any questions about anything he said, we can try to answer them at the end. Now I'm going to talk about the software. So a lot of people, they think CNC must be really hard to learn because I don't know how to use the computer to design. How do I get into this, right? So today I'm just going to show you this. We're running Aspire Vectric software. This is their top end tier software. Most people will just opt for the VCarve Pro version, which pretty much does almost everything. This one has a little bit extra 3D feature modeling. If you do a lot of 3D modeling, this might be something you look into. And you can always upgrade if you get the VCarve Pro. You can always upgrade to a higher tier if you find yourself in need of those extra features. But VCarve Pro, I would say more than 90% of our customers are running VCarve Pro, and they've been very satisfied with it. So you open this up, and really the first thing you want to do, we showed you the cutting board earlier. So you want to do your job setup. So you want to enter your material information. So how big is the piece of stock you're going to work with? So in this case, you can do we're going with 20 inches on the X, which is the width, and the Y on the height, 20 inches. The thickness of the board is 0.87 inches. Now moving down is the Z0 position. And this basically means where the spindle is going to be calibrated. Are you going to calibrate off the top of the surface, or are you going to use the machine bed? So these are two methods that you could use, and they have different advantages for each. Machine bed is especially good for if you're trying to cut through the material. You can enter in your correct thickness, touch off the bed, and it will raise above the thickness and cut all the way down to the bed, and it actually will minimize cutting into your spoil board because it will know exactly where you touched off the bed. Material surface is good if you're trying to get very good, accurate depth of cuts. You're not really worried about cutting through all the way, then you could touch off the top, and that will give you a more accurate cut. Moving down is the Xy Datum Position. So this is kind of the starting point. We call that the origin. So when you set up your workpiece, which I'll kind of show you guys in a bit on the machine, basically in the software, you want to match whatever, and on the machine and the software, you want to match this. So if you set the middle, then you're going to set your spindle off the middle of your material stock. If you set the corner, then you're going to set off the corner of your material stock on the machine. I usually go off the center, and this is really just personal preference or depending on what you have going on, if you have jigs set up or not. Moving down is the model resolution. That's really just for display graphical. If you have a slow computer, you could do you could lower it so that it could display the 3D modeling a little bit quicker. And these are just the appearances for your previews, which you'll see later. Once you have that set up, you basically say, okay. Now this white square is basically what you just entered in terms of the size, X and Y. And then now, well, we're going to show you some of the features. So it's basically like a drawing program. You know, you could do your circle shapes and your squares and ellipses and all that. You could do lines. You could easily do texting type of cuts. You just type in your words. You have your fonts already, and you can install basically any font you can find, you can install on here. And you'll be able to basically create a vector file for cutting. So extremely simple. And then there's, you know, transforming, changing the size. Once you import it in, you can mess with the size. And there's a lot of extra adjustment tools that you could really fine tune your design. But today we're just going to cover some of this bitmap, trace bitmap feature, which is extremely useful because you could take a regular image, for example, like a logo, and just basically trace it. It's relatively quick. So let me just grab an image from the net. Sorry, I had it already, but I guess probably got deleted by accident. So just bear with me for a second here. Literally downloading it very quickly. All right, so once you have your image, I literally just downloaded this. Yes, that's a good demo of how quickly you can get this. All right, so there you go. Now you got your image and you click the trace button. Now, basically, it's taking the colors and shapes of that image, and you could do black and white. You can change the darkness of it depending on the image that you're trying to chase to get the effect you want. You could do filtering by color. You could do less colors, more colors. I mean, this image is pretty simple. There's only 2 colors. So in this case, like black and white will probably work the best because we're really just going after the shapes and lines. And once you have that looking good, you basically click preview, and there you go. It will basically trace the lines already for you based on that. This is like good for business who making logos. You could put someone's logo on here, trace it, put it on a sign, and cut it out for them. These are corner fitting type of tweaking. So do you see the curve? If you want it more curvy, then you could drag that. You could preview it. If you want it tighter, you could change it. It gets more edgy. So it's very simple in terms of trace. We use this all the time to trace basic designs. If you try to upload a more complicated, like a person's face, it's not going to come out good, but it is very useful for other simple shapes. So once you have that, you hit apply, okay, and you could pretty much get rid of this image at this point. And there you go. Now you have your lines and shapes. So now what? So basically, once you have your design cut out, you basically want to assign what we call toolpaths. Sunny showed you the bits that we used. So a lot of the common ones. In this particular project, we only used basically a surface bit to flatten out the piece of wood, and we used the end mill to do the male portion of the inlay and the female portion of the inlay. So I'm going to show you quickly how to create the toolpaths and what that kind of looks like. So I already pre-did this earlier, so we don't need that one I just made. But this is the one we worked with. All right, so basically two parts, male and female. So let's start with the male portion. VCarve has a couple different type of toolpaths. profile and pocket is pretty, I would say it's the most common ones that you use all the time. And then you have your V-carve bit, which is really good for letters and signs and gives you that V effect on the edges. So, and then the inlay toolpath is basically created for inlays. And what this toolpath does is it calculates the radius corners created by the tool bit and make the two pieces fit together properly. If you had to do this manually, it would be pretty difficult. But with this function, if you create your toolpaths with this, it will account for the radius for the male and female. You could enter in different offsets for either the male or female so that they can fit properly together. You could change the offset so that you can adjust the tightness of the fit. So in this case, we use a 0.008 offset on the pocket portion. But once you go into the toolpath, you have your depth of cut. So this is the full thickness of the stock. So we're cutting this whole thing out. And we're using a 1/4 inch end mill. And if you go into the tool, I'll show you guys some of the settings. This is where some people kind of get confused. Like, oh, what should I put here? They just go with the default setting. So definitely don't go with the default setting because each machine is different. Some companies advertise rapid speeds, cutting speeds. Like it's some rapid speeds advertised out there I've seen. There's no way some of those machines are cutting at those speeds because when you're cutting, the force, the build quality of those machines, realistically they're not going to be cutting at that speed. So when you are looking at those rapids and cutting speeds, you really want to be careful what there is listed. So in this case, for the I2r 1/4 inch end mill, it's the diameter. Now you have your pass depth, which is basically each pass the tool takes, how much material it's removing. This is important because if it's too deep, you'll cause too much stress and it will maybe bog the machine down. And this is why the strength and the build quality, the rigidity matters. Next is the step over, which is basically just how much the bit shifts over each time. Then you have your spindle RPM, pretty self-explanatory, 24,000 RPM. Inches per minute. And now this is the feed. This is the horizontal movements, vertical movements in the material, the X and Y. So how fast is it moving through the material? So this is also very important depending on the material you're using, the bits that you're using, different bits. You know, bigger bits can go a little faster, smaller, you don't want to go too fast. You could, depends on the result. So you kind of have to play around with it a little bit, depending if it's a new material. The good thing about I2r is that we actually provide you a little spreadsheet with feeds and speeds for all the common bits, common materials. So you kind of have a good starting point. But for in this instance, we're pretty much going with 78 inches per minute and 31 plunge. Plunge is the Z-axis, how fast it will dig into the material. Still important, but the feed pass depth are, I would say, the more important ones that you need to look at and pay attention to on any CNC machine. All right, so once you have that set, you click OK. So in this case, it's going 7 passes. And the good thing about this software is it gives you a preview. You click calculate. It took your parameters you just set, 7 passes. You can see the lines, 7 passes. Preview the tool path. Gives you a little rendering of how that's going to look. This is very useful. So this is kind of what we're after for the male inlay portion. So that looks fine. That looks good. All right, next I'll show you the female pocketing toolpath. Very similar settings. This time we're just going 0.4 inches deep. We're using the same exact bit. When you do inlay, you always use the same exact bit. Not the same size, the same exact bit that you used for the male. Just because all bits are not created equal, even though they say it's 0.25 inches, if you use a different bit, you might not get the same result. So always use the same bit when you're doing the inlay. Same thing, same settings, pass depth, all the same settings. Everything is the same except for the pass depth. We pumped it up a little bit at 0.25. This is more of an aggressive cut, but I2r can handle it, so that's what we went with. And then same thing, you calculate that. And great thing about this is the preview. That's the travel of the spindle. You preview that. You can see how that looks. Generally, if you enter in the good parameters and the tool bit correctly, this is what you're after. 100% of the time, probably not going to come out all the time, but sometimes things can go wrong if you miss the setting or you overlook something. So that's why it's always important to look everything over, double, triple check before you hit start. So there you go. That's kind of the preview again. And once you have that, you're happy with the preview, you double check your settings, everything looks fine. So basically in this mail inlay tells you the time it's going to take, about 10 minutes. For pocketing is about 6 minutes. Obviously this will vary depending on your settings. If you're doing more passes, bigger projects. So this is a relatively quick and simple project. So these are time estimates are also good because you can look at the time. If it's like, it's 2 hours, can I change some settings to maybe bring it down to an hour and a half? So you could play around with the settings until see what you could get away with. You want to cut fast, but you want a good finish and good final product. So once you have that, the next step is to save these created toolpaths onto your desktop. You're going to output the files out of this into your PC laptop so you could load it up in the Cnc software, which Sunny showed you earlier. And this is relatively simple. The hard part was already done. So now it's basically just clicking which one you want to save. You pick your post processor, and that's basically the format of the G code that is outputting for all these different machines out there. vCarve is very popular software, so it's used by a lot of CNC companies. So for us, it's a Mach 2 arcs millimeter. Once you set this, it pretty much defaults to this every time. You see the list. There's an extensive list of other CNC machines out there, and that just tells you how popular this software is. It's because it's very easy to learn on. All right, so once you have your post-processor set, you click save, you give this a name, Batman, female, maybe put the tool size. If you have a lot of tool paths going on, it's always good to name it something that you know exactly what you are clicking on. All right, so, and then so you do the same thing with the mail. You just highlight it with a check, save, mail 0.25, save. Okay, so that's it. Now you have those files on there. So now we're gonna head over to the CNC, and I'll just show you quickly kind of, once you do that in your software, what are you gonna do to set that up on your machine? So just give me a moment to walk this way. Switch 1 second, guys. Big marker. Sorry about that. Let me just get back to the video. Not video, camera.
I think your camera is off.
Yeah, it might be. Might have. Sorry about that. Technical difficulties. All right.
Oh, there
Are
you
back?
go. Yep.
Back. All right. All right. So as you saw, we saved it on desktop. Now, I think Sunny has it on here. Okay. So you load up. This is the mail inlay toolpath. So now that you have your image here, you got your stock material here. So if you remember, the middle of the stock is where XY datum point. That's what we set. So generally, you would mark a X on your stock material, right? You would clamp this down with your clamps. In this case, we use double-sided tape, so we didn't have to worry about clamps. We use wood double-sided tape, which is a very useful hold-down method, and I've been using it a lot. It's quick to set up, easy to remove, and it's relatively reliable. So you'll see later in the footage that we basically didn't use any clamps, but I'm just telling you that most of the time you will use clamps. So now that you have loaded it up, you're gonna move your spindle to your X that you marked, right? You're gonna move it down to the spot. Try to line it up as best as you can. And this is also where the pendant sometimes could be useful, because you could get really close and try to get that pinpoint so that you have the correct position. Once that kind of looks good, you say, all right, you're gonna zero out your X and Y. So you hit X and Y 0 individually. And that basically resets your working offset that, okay, this is where it's going to start cutting from. And now you move, the yellow dot is where you're going to be cutting. So this is useful in this software because you have this preview. Once you set it, you have your yellow dot is tracking lifetime where it's moving. So if you, for example, if you had clamps here, you could say, all right, I'm going to cut along these lines. Is my clamps in the way? If they're in the way, you need to move them. Do I have enough material to cut? Is everything looking proper before you hit start? Once that's set, you set your Z-axis. The Z-axis with the touch-off tool that we have, which Sonny displayed earlier, it's extremely easy. You just plug it in on the side of the spindle. You put the puck right under the spindle. You hit the probe down button on I2r Cnc. And there you go. It touches off, goes raises, and now your Z-axis is set. You could get this out the way. And this is where you pretty much kind of just sit back and hope everything goes well. So I'm going to show you some of the pre-recorded footage that we have, because this thing could get a little bit loud and it may not be as suitable to just sit at home watching this for 20 minutes. So I'm going to show you the process and kind of walk you through this stuff on the phone that I created. So let me switch over. All right, so as I mentioned earlier, the first thing we did was use the surface bit. We flattened out the first piece. This is the male piece that we're going to use. We just had some, I believe it's like walnut. We had some laying around, so I flattened this on both sides, just so we could start with a nice flat piece. All right, so that was the male. And then after it was flat, we moved on to doing the cutout for the Batman signal. So this is just like, you could hear the sound, you could see the spindle. This is the same exact machine that we have here in our shop that you guys are looking at. All right, now it's just the circular portion of the male inlay. Here, get an idea of the sound and the speed. Sorry, skip. Oh, not good. Okay, so that's pretty much done. And as I was saying, we use double-sided tape. So over here, I'm pretty much trying to record and remove. And as you can see, I'm having a little trouble there and it popped off. So double-sided tape, definitely look into it if you haven't tried. Very useful. Apparently they're in high demand now. Some customers telling me it's hard to get. So if you could get some, you probably should stock up. All right, so that was the circle piece that we're using for the cutting board. There we go. That was pretty much the last piece. And I'll show you the double side tape on the back real quick in the last few seconds of this. There you go. Okay. So we did the same thing for this is the maple cutting board portion. Flatten both sides, same bit. Once that was flat, we did the pocketing. Same exact toolpath that we demonstrated in the software. As you can see, this is a compression bit, 1/4 inch. This machine can handle wood with 0 issues. You can cut pretty much all day long. We have customers using this, cranking out tons of signs every day for their business. Here's that last shot for the pocket. This is where you could kind of sit back, relax, you know, go do some other projects, work on it. You should definitely keep an eye on your CNC though still, but that's the great thing about having a CNC. It's like having another person in your shop. While this cutting, you can work on some other project, work on another design. Once we cut that out, we basically do a little test fit. The reason we cut out the male piece first is that if for some reason the fit's not good, you can make adjustment in your settings right on your computer real quick and do one more pass on it. And that's exactly what I did. So I didn't want to go too loose. So I had to incrementally increase until we got a good fit. Once I was happy with the fit, I basically glued it in, left it overnight. And the next day we pretty much came over and pocketed the excess out to get a flat surface for the inlay. Once that was pocketed away, we went over again with the surface bit, just to give it that once over, smooth finish. Good thing about the flattening bit is if you don't have a planer, you could still use your CNC. It's not as fast, but if you don't have one, or if it's for whatever reason you need to do this, like a lot of people do use this. Okay, so this is basically right after it was done. We took it to put some Odie's oil on it, just to food safe product, mineral oil, Odie's oil. It's really just, you can see how smooth it is. There's no sanding really needed after this. There's a picture. Another picture, and then the last picture is basically after the Odie's oil. You can see this was my kitchen. Now it's back in the shop. And that was pretty much it. So I'll just show you guys one last time. Simple project. You know, you can make this. It's a useful item. Everybody needs a cutting board. All right. So that about wraps up our demonstration for today. I think we're pretty much ready for a Q&A if anyone wants to jump in.
Yeah, so we've got some maybe we should break it up into questions about the machine and then questions about the software. So let's see. Let me go back to my tab here. Brandon wanted to know that he kind of sees himself eventually getting a 4x8 machine. Is he crazy if he wants to dive in from the start with a 4x8? And I want to add to that. I have a few friends who have a 4x8 and have told me that they use the front 2 feet and that's about it. So what have your customers that you've been, because you've got people that you've been working with a lot for years now. What do they say? And what are your experiences?
I mean, 4x8, I guess the question I would ask him is, what is he using it for? Is it for business? Is it for hobby? Mm-hmm. Do you have sufficient space? Because that 4x8 is a relatively large machine and generally used in usually production, not so much like hobbies here. So I'm guessing he has a business of some sort. And if it is
Brandon is telling me he wants to engrave and carve tabletops. Think a map on the tabletop. So I guess that kind of dictates the size.
Yeah, exactly. So if you have a specific use for it, CNC is a great tool. It's an awesome investment. And if you have that particular use, if you have the budget for it, like the technology, has come a long way. So I wouldn't say you're crazy. Like if you got the money and you're selling a lot of doors, you know, by all means, if it makes sense, I think it could be a good option.
Yeah, I've actually had a customer like last month. They were looking at our 2x4, and then they wanted to step up to the 4x4. The question that I asked them was, how much money are you willing to put into his investment? So if he's got extra cash to put in on a 4x8 system, that's great. But I would incrementally take a step to a smaller machine first, and then make sure that idea is actually going to generate income back before you dive in and make that big investment. Because I mean, depending on a 4x4 or 4x8, even a jump from 4x4 to 4x8 is a very big jump. But if he's ready, locked in, he has a machine, he could take what he learned today and look for a ball screw system. Like if he has companies in mind, ask them those questions. Like, is it a rack and pinion system? Is it lead screws? Like, where is it made? Like, who's making it? What's their experience? So if he really wants that 4x8, we don't have those machines yet. The larger we go up, as I mentioned, is a 4x4. But even from customers jumping from a 2x4 to a 4x4 machine for us, we always tell them to first learn the type of setup from start to finish. Are they comfortable with doing it? Are they going to have time to use the machine? Because like you, Ben, even on your smaller machines, like you might have used it a few times and then it's sitting there in the corner. Talking about this investment, it's a lot larger, so I'm sure he knows what his use is.
Well, another thing that I always think about when I think, you know, when I'm ready to take that plunge is, I don't have room for a 4x8. If I did, I would maybe use the 4x8 table 2% of the time, you know? So maybe for those jobs, those are ones that I'd hire out, you know, and go with a 2x4 or 2x2 even. Let's see. We had another one just pop in that was really great. When looking at the website for pricing, what comes with the machine? You talk about a toolbox. Obviously, the laser is an add-on, and the fourth axis is an add-on. So if you buy your base machine, what is David going to be looking at?
So for the base price that he's paying, if he gets the machine by itself, the stand would be extra, but he gets the limit sensors, the Cnc software, the Z automatic touch-off tool. He gets the MDF spoil boards, and then he also gets 1 year manufacturer warranty, free from defect, and free lifetime support.
Wow!
And also comes with the control box, of course.
Okay.
We also offer flat rate shipping of $199 anywhere in the contiguous U.S.
Just because it's something that I really get into, you had mentioned it, the X-axis touch-off tool. That's the thing that, so it's basically you're perfectly setting where the top of your workpiece is with that, right?
Correct. So the Z touch-off, it calculates the tool length automatically for you, and it calculates an offset for the thickness of that probe that we have. So it's a click of a button like Fu showed earlier, and that's included with the machine.
Okay. Paul just asked, and this kind of bridges the gap between software and machine. Do you find it necessary to build tabs into your tool paths when cutting through material? So, and I guess that would add the question, when you do that, do you build tabs in at VCarve, or does UC Cnc do that? Explain tabs to people who are new to this.
So in this instance, Fu, I don't think used tabs because he had the tape, and that was holding down the material and locking it in. Tabs are necessary, especially if you're just using the hold down. So when you're cutting out, let's say that Batman logo, once you do that final pass on the bottom of the board, it would eject out if there were no tabs holding down the rest of that piece. So tabs is something you would load in and set in the VCarve, and then that is all calculated automatically, put into the UC Cnc software. It's a quick setup. It takes like maybe 10 seconds. Let's say you wanted like 1/8 of an inch on tabs. You can go as thick as you need, but generally the thinner the better, because it's less hammering with the chisel at the end when you're trying to take it out. Also, you also have to think about sanding, trying to sand and smooth out the tabs on the side. So it also affects the aesthetics of your final look that you're after.
Yeah,
Yes.
I would say most of the time you would use tabs unless you have like a double-sided tape or a vacuum table setup. You're going to need tabs. Like Sonny said, the thickness, you could fine-tune it so that you have less work later on. If you don't have to put a ton of tabs, just enough that it won't fly out, just thick enough that you can get it out without damaging the back of the piece.
Yeah, I made the mistake one time of not adding tabs, and like right at the end, you're watching it, all of a sudden piece starts to wiggle, and
It
you go,
shoots
"Oh
you.
no!"
Yeah. Well, been there.
As part of the process.
Yeah.
Okay, so a couple of questions about so the spoil board. Oh, I'm sorry. What size MDF comes with the machine? Is that 1-inch MDF for the spoil
Yeah,
board?
it's a little bit more than 1 inch.
Okay.
It's like 30 millimeters.
So you can actually remove it with the T-slots if you don't need it, and that gives you an extra about inch plus some change to give you more Z clearance as well.
But when those are spent, you could go with 3/4 or whatever you have lying around.
You can
right?
take any type of boards, MDF, and just slide it on, and that's why the T-slot track is so useful, because you can clamp that down and then put your actual material on there. We also can help you get these. They're very, very popular.
Yeah. And we have dimensions if you want to make your own. We could send that to you, and you could always make your own on your CNC or by hand.
So, a question about the limit sensors. I know in my old machine, I didn't have limit sensors. So it would be going over, and the controller thinks it's still going. And in the meantime, the belt is just slipping, and then it winds up going off and absolutely obliterating the workpiece. Do those limit sensors communicate with the UCCNC software so that it knows it hit the limit sensor, or does it just stop the arm?
Yes, so the limit sensors are magnetically engaged. There's a plate, so that when it reaches the max travel, a signal is sent to the inputs on the UCCNC, and that's read by the board inside, which we use the XBB board. That's the hardware. So once it knows its position because you're homing the spindle at the start of each job. So when you home, it's moving it along your X, Y, and Z to the 0, 0, which is the front left of your machine. And that basically calibrates your working coordinates with your actual machine coordinates.
Okay, so but it's kind of a closed loop system.
It's open loop system because you're talking about stepper driven systems.
Yeah, okay.
If you're talking about like a servo, which we have on our like 4x4 and larger, those are closed loops because there's constant feedback getting sent back. The open loop on the steppers is just that once it gets out of there, it's going to know before it hits the max travel because of the sensor being there.
But it'll stop itself from like obliterating itself. In other words, okay,
right. 100%.
We have from Angel Garcia, who I believe is both a customer and of yours. I think they said that they have a I2r 8.
Right.
They are requesting that you make a YouTube video on maintaining the system. What is maintenance like on a CNC?
So a lot of people think that like maintenance on this type of system is very difficult. It's easier than changing the oil on your car. Like that's a very complex thing compared to this. Our maintenance, especially because it's a ball screw system, as I mentioned earlier, it's as simple as taking standard grease, engine grease, and applying with a thin film directly on the ball screw and just jogging along the axis on each position. And that's also why the open bottom of the stand is very handy. So if you build your own stand, we have customers who do build their own stands, but typically it will be closed. So when it comes time to try and maintain that ball screw underneath, they have to find a way of lifting that. And it is a light system, but it's not the lightest. So if you like to move it around on your own, good luck. But other than that, every day, once you're done, vacuum, blow it off with air. That's the typical maintenance. And the cycle of ball screw systems, like minimum of 15 years before you even have to think about changing them out.
3-in-1 oil, pretty much. That's
also
on the guides, and ball screws too, like after every use, and just wipe it down.
Keep it clean.
Yeah, the grease zerks you don't really have to touch for probably a 500-hour runtime before you have to touch that.
Okay.
Yeah.
Angel says Semper Fi. Marines stick together. Okay, so let's talk about software. Right off the bat, we have some compatibility questions. Robert is like me and a Mac fiend. vCarve's not going to work with Mac, right?
No, not directly.
You could run Boot Camp on your Mac with the Windows OS, and then you could run both UCCNC on and vCarve on that.
Okay.
But another popular one is Fusion 360, which does work on Mac. So a lot of customers use that. So you could always do your CAD CAM on that on a Mac, but you still need either Boot Camp or another Windows to run it on the CNC.
So I know, or obviously I work out of my shop and I have my computers and everything, and our IT guy is not fond of me operating all of my expensive computer equipment in the wood shop with all of the sawdust. So I think if I got a bigger CNC, I would dedicate a laptop to controlling it, and you just go with a Windows unit then, right?
Yeah. I mean, if you run a really good dust system, it would minimize a lot of the dust. But that's just, that's a tip.
Yeah. Even so, like your laptop's going to be able to handle it. I run my machine with aluminum chips and dust gets all over it also, even like cork. I just blow it off with the air gun and it's still working. I mean, PC's been around forever. It's not a fragile thing. So it can work in that environment too.
Yeah.
It's understandable. MacBooks are like 5G, so I get it.
Not the one they get me, I'll tell you that. What about Linux? Do we have David was wondering about Linux.
Yeah, that is not compatible with Linux. It's only a Windows system.
Okay.
It won't work with Chrome either.
Okay.
Yeah. No
Chromebooks or whatever. Yeah. Gotcha. Okay, so David also asked a question. David's digging in deep here. Does the software support variable plunge depths or tool steps? And I tried to answer it, and I answered it with the dumb answer, thinking that he was just talking about step down rate, but he actually meant if he wants to cut, heavy and then right at the end do a finishing pass or something like that. Can you program in finishing passes?
Yes,
with vCarve?
And you can do that all within vCarve, and you don't need to put in extra G code. The vCarve allows for all of that, so it's all click with the mouse.
Okay, so it's a checkbox. Can you even do climb cutting finish passes? Or I know on Fusion you can.
Climb, yes, you can. There's different types of. There's like a box you can check off even threading. You can do that as well if you're trying to put in threads on your drill hole, something like that.
Okay.
Yeah,
and it can tap holes as well.
So there's a reason why everyone
like a second. You could do a second toolpath. Like if you just want a finishing one pass over, you could just make one more toolpath to do that. I know Fusion does have more functions in terms of how to cut, but vCarve, I believe, does the same thing, but it might be a little different steps.
Just to clarify, we do have customers who use Fusion 360 with our machines too.
Yeah, but you would still be trying to get the first thing done of the Batman thing in Fusion. I'm digging it deep with Fusion. It is not fast. It is not a speedy program. Okay, so Cal Barnard, who is waiting for his I2r 6 right now, he says in the meantime he bought a laptop from Tiger Direct for about $200 used. It'll stay in the wood shop. It's an i7 processor. So it sounds like you have swayed Cal into an I2r 6. And he's got a dedicated machine to run it.
We're working on getting your machine,
And Brandon's adding in right now that, and this is big for woodworkers, you can export straight from SketchUp into VCarve, which is really good to know. Our audience loves SketchUp, and for good reason. It's an easy to use software. Okay, so what else do we have? The questions are starting to come in, so I'm trying to catch up. First time user large format. That might be about it. Oh, real quick, you've been mentioning ball screws. And you had mentioned early on like the rigidity of the frame and all of that. Ball screws are new to me. And I'm sure machinists, I hear, like when I watch machinists videos, I hear ball screws all the time. But what's different between a ball screw system and like an Acme thread system, if you don't mind?
What? Acme?
An Acme thread or just a threaded rod? Yeah.
Acme, they most likely use lead screws. So lead screws don't have ball bearings. So there's different types of ball screws. So like on ours, in the ball nut, if we're talking about the ball screw itself, it's enclosed. It's an enclosed system. So the ball bearings are preloaded, right? So there's less friction and there's less space. So there's no play between the ball screw and the travel of the ball nut. So as you're moving as you're creating that circular motion into linear motion, there's going to be zero backlash. So that allows for the computer to calibrate and set that. So if you have other systems like lead screws, there's more backlash. So because there's a lot of backlash and return going back into the computer system, it's trying to figure out how to evenly distribute all that vibration that's going around the cuts. So ball screws are backlash free. So they allow for high speed machining at rapid rates, and you can accelerate and decelerate because of the ability to distribute all that motion.
Okay. And there's just no wiggle room in a ball screw. And
no,
like,
none at all.
I know my belt, my little belt unit. When you were pushing down on that Z-axis, I was like, holy crap, that's that's totally different.
The only thing that would affect the ball screw is the alignment of the frame during assembly. But as long as that's why when it comes to ball screw systems, there's a lot of care and design and assembly that goes into it. You can't cut corners. So compared that to like a lead screw system, there's no ball screws. There's a lot of backlash. So that's one of the reasons why ball screw systems are also, they cost more, right? But in the long run, they last a lot longer as well.
Okay. Great question from David just popped up. What is the maximum cutting area of a 24 by 28 machine?
The 24 by, sorry?
48 so the I2r 8 behind you, that's a 2x4 machine, right?
Yes. You'll be able to cut 2x4.
Oh, so it actually cuts 2x4.
Yes. So the bit,
account for the bit diameter.
For the bit length. Yeah.
Yeah. So the travel is basically 610 millimeters.
Okay.
Which is like 24 point something. So you could travel that much. And same thing on the Y, but you have to account for your bit diameter.
Okay, so
it's a smaller bit.
On a lot of machines, a 2x4 machine would actually have a cutting. So that is something to look out for, because to anyone looking at CNCs, the cutting depth or the cutting area is not always the bed area. So keep that in mind. What Stefan asked, what thickness material the Z-axis can handle?
Depends on how long of a bit you're using, but typically the entire throat is about 5.3 inches. But if you have a long bit, then you have to account for that. And I mentioned earlier, you can also remove the MDF. So that gives you an extra 1 inch.
Sean Mahoney. I went to high school with a guy named Sean Mahoney. I don't know if it's that guy. Sorry. If you had a longer piece to do, can you cut it in 2 phases, like reposition the piece in the middle?
Yes. So you can, in VCarve, do what's called tiling toolpath. You can take a whole board, Kind of like this board, we did that out of the tiling toolpath, and you can cut it up and feed it through. It's only going to be through the Y axis though.
Okay.
This way.
And it is not the Sean Mahoney I went to high school with, just so that everyone knows now. Okay, so are there any other questions? There's some Q&A here. Oh, I got Stefan's there. I think that about does it. If it was a separate, okay, hang on one second. From Paul, was the first flattening pass you did with the surfacing bit on the cutting board a separate tool path, or is that pre-built, or is that a pre-built function in VCarve? If it was a separate tool path, did you have to re-zero the Z-axis and before the next tool path?
Yes, every time that was a separate tool path. Like I showed which tool you're going to use. So every time you switch the tool, you do have to create a new tool path. If you're using the same tool for several tool paths, you could save it in like one run, for example. But if you're switching the tool, you have to make a new tool path and you got to touch off again. But that's kind of what the Z-Touch puck is good for too. So when you do change the tool, you don't have to worry about it. You just, as long as you have a surface to touch off. If you're already surfaced, you could touch off the bed. You could, if you have a spot, you could surface again, touch off again. You could use the touch off puck, but you do have to use it again.
Do you have to rehome after you change a bit?
No, you generally don't really need to rehome until you're done.
So is that because of the stiffness of the machine that it's not going to move while you're changing the bit?
Yeah, it's definitely not going to move when you change a bit. I basically home when I turn it on, and I don't home again until it's done.
Okay. You can tell I've only used junky CNCs, so.
Yeah.
Okay. Let's see. We've got some AutoCAD to VCarve questions. Do we know how that workflow goes? Robert's asking.
It depends on the post processor.
Okay.
So I think Inventor, some schools, they said they might, it's like, because AutoCAD is part of the Fusion family. So they might have something, but you probably have to ask AutoCAD if they have a UC Cnc or a Mach 2.3 type of post processor.
Okay.
There's a bunch out there. And some companies actually can make it for you, or some people can customize a post for you.
Okay. Scott Orr wants to know where your machines are made and assembled.
They're manufactured in Taiwan.
Okay. And you put them together there, right?
So all the manufacturing is done in Taiwan, except for the setup for the control box. We designed that in EU with our partners.
Okay.
We go through every machine here before we ship it. So we open it up, we run through, make sure everything's operational, and then we pack it back up. So we QC everything again, basically.
Okay. Yeah, you guys posted last week. I think there was like a line of like 6 CNCs that you were going through and figuring it. Yeah. Brandon says everything should be ball screw. All right. Any last minute questions? Speak now or forever. Oh, Brandon, I just found another one. Let's see. Talk about the lathe attachment. I wonder if we should show the.
We have time. If you want to show them, they can, or even log on to our YouTube, I2r Cnc.
Well, let's real quick play.
Yeah, let's do it.
What is my favorite video on the website? Thank you for indulging me. I just think that's a cool video. My son's into Star Wars, so you're hitting all of the points for me. Robert Bailey just said sold. Okay, so one last question. We're gonna get this one in. David Seeley needs a little bit of clarification. All right, we got two questions. Robert, one of my favorites, Robert Millard Mendez chimed in too. So David Seeley, can I put a 25 by 31 inch board on a 24 by 36 inch unit and carve it to 24 by 30? He's very specific.
25-inch.
So will a 25-inch board fit in the y-axis?
In the X, it would fit.
Yes.
But like we mentioned with the travel, if you're cutting, if you want exactly 24 inches wide, you might have to turn off the sensors and see if you could get away with it before it hits the limit.
And then you void your warranty or something, right? That's
it's basically because like the soft limit, it travels 24 to 20, like 24. Mm-hmm. That's the travel. But then if you're cutting out a piece, you have to account for that bit diameter. If it's a 1/4 inch bit, so it will be a little bit less on each side, basically.
Okay.
You go down to a smaller bit if you want, but I think you have a good inch on each side of the MDF, maybe a little more. Okay. So physically, you could fit a 34. He said 34 inches?
Or 25.
25. Yeah.
So that'll fit. Doable, but it requires extra thinking and work. So if that's something he's looking to do regularly, he might need a bigger machine.
David just said, okay, so 48 by 48 it is.
Yeah.
Okay, so Rob asks how the MDF, I would assume the spoil board strips are held onto the table. Are those screwed in or?
The T-slot bolts.
Yeah, these little nut and screw.
Yeah.
And you can take them out with the Allen key.
Okay. And David brings up a good question. I lied. Here's one more. David brings up a good question that I was tooling on the website too, and I saw the vacuum table option. David wants to know more about the vacuum table option.
Okay. The vacuum hold down table, those are right now strictly reserved for our executive series. So you can't get them on our executive series, but right now we don't have them available on the I2r yet. But it won't be anytime soon. I'll just leave it at that.
We are working on something to come out.
Okay.
And we have some people who made their own vacuum table on the CNC.
Okay.
But, it is in the plans, but we don't have anything right now for the I2r. It is on the exec available.
So it's available and it's not available. Just putting it out there.
Okay, so Angel's saying they're a fan. I2r is awesome. I like the quick response on their website when I have a question. It sounds like you're really interactive with your customers.
Yes, customer service is our #1 mission statement, if you want to say it.
And is it you too? Like if somebody sends an email in, are we getting Sonny and Fu or?
Majority of the time you'll get one of us, but then you might hear from someone else from time to time. But majority of the time we'd like to be the face and interact with our customers.
Yeah. Okay. Let's see. All right. Well, Sonny, Fu, I think that we've covered everything. How can people get in touch with you if they have questions that have gone unanswered?
So if you have like a long email for you to email us, if there's any other questions you weren't able to cover it, info@I2rCnc.com. It's info@I2rCnc.com. Or you can log on to our website, I2rCnc.com, and message us. We always definitely recommend leaving your email address in the chat flow since we try to get through as fast as possible. But once we have your email address, we can quickly respond also. And then follow us on Instagram, I2rCnc, and also our YouTube channel and Facebook. We also just started a brand new forum on our website. We moved from Facebook, which is a private owners group, and then we just launched a public forum too. So if you guys have any questions, also feel free to get on there, post, see what everyone's talking about. We're really building a nice community to spread CNC technology, because we're very avid believers in, like, you should be using CNC as part of your woodworking.
I fully agree. It's amazing what you can do, especially with the 4th axis. It's just, yeah, I'm saving up. So, okay. So, anybody who was not able to get your questions answered, please email sunnyinfo at I2rCnc.com. And I will put that information on the Fine Woodworking website. If you want to go back and watch this, it should be up tomorrow afternoon, March 12th. Tomorrow afternoon, I've got a podcast in the morning too. So I'll get this up as soon as we can. And thank you, both of you. This was awesome. That machine is incredible. Thank you for showing us the software.
Thank you, guys.
Yeah. All right.
Thank you. Appreciate you all coming and taking the time, and hope you enjoyed it.
Yeah.
All right. Everyone, have a good night.